Okay, hi guys. This is a bit unideal. The video looks weird, it's all flickering, there's a weird bit of light here, sorry. I couldn't find a good video online really to explain this technique, so I'm just throwing one together for you. Okay, so the technique that I'm going to talk about is colorimetry. I'm just going to talk you through the very basic principles of it. If you had to explain it to a small child, kind of bog standard in a nutshell kind of description, and just show you kind of a schematic diagram of how the equipment works. So colorimetry, you might guess from the name, is to do with colour and light. It's to do with the idea that if we have a sample and we have something in that sample and we don't know what concentration it is at, if that thing has a colour, we can use this technique to figure out how much of it there is in there, and I'll try and explain why that is. So let's just imagine we've got something in here. Let's imagine it's iron and it's a kind of green colour, okay, when it's in solution. There's a really convenient relationship called described by the Beer-Lambert law. You can look this up if you like, but what it says is that colour intensity is directly related to concentration. Okay, so if we can measure the intensity of the colour of something, we can mathematically figure out how much of it there is in there. Okay, so let's imagine we've got our colorimeter. The colorimeter is made up of a light source that outputs white light. White light, as you know, is all of the colours combined. If you split white light through a prism, you get a rainbow. So that's what's going on here. Then if we would pick our filter depending on what the colour was in our sample. So different things will absorb at different wavelengths. A way of thinking about this is, if I had a banana here, it would look yellow, and that's because all the white light is falling on it and only yellow light is not being absorbed by the banana, it's being reflected into my eye. Okay, so things look the colour. My shirt looks blue because it's absorbing all the other colours, but blue is being bounced back into our eyes. Okay, so different substances absorb light of different wavelengths, and that's how we see colour. Here, if we've got something that is green or is absorbing all like wavelengths apart from green, we will set this filter to let through the wavelength of light that's going to interact with this sample, that's going to be absorbed by the substance in here. We've then got our sample, so this particular wavelength that we've chosen is let through here. If this sample is just water and is colourless, 100% of this light is going to go through, and we would get that detected here, and it would be converted into a digital reading of 100% transmission. 100% of the light passed through that sample because it's clear and colourless. Nothing was there absorbing any light. We might also call it 0% absorbance. So it would be 100% of the light would be transmitted, or we could describe it as 0% of the light was absorbed. If this was a really, really strong colour, this light would come and pass through it, much of it would be absorbed, and then detected and reported would be a much smaller number. It might be a high absorbance percentage or a low transmittance percentage. So this is basically what you've got. Light source, we use the filter to select the wavelength or the colour of light that we're going to let interact with the sample, and we'll make that decision based on what colour this substance is. This wavelength of light will pass through our sample. If it were colourless, all of it will get through. If it's a very strong colour, not much of the light will get through. Or if it's medium, you know, if it's a bit opaque but a bit transparent, maybe half the light would get through, and we'd get a 50% absorbance or transmittance. Bit of a crazy run through, but this is what we're working with at the moment, isn't it? I'll be in the Teams chat if you've got further questions about that, but I hope that gives you a kind of an overview.